Right. So I told you about the ENIAC computer last time, and you can see at the same time, around the same time, this is about the second World War. Everything started to develop exponentially. So like we had the Bayesian data analysis. It's not what it is, but it's a very important branch of mathematics and statistical science right now. And this is actually most of my work, the Bayesian data analysis. And then we had the stochastic methods, which is the basis for most of the optimization, most of the popular optimization methods. And then if you search for the word computer in Google Ngram, this is a result from Google Ngram. Yeah, how many of you know about Google Ngram? Nobody? Okay, a few. Yes. What you can do with Google Ngram is that you can type whatever word you want, and it gives you the history, the frequency history of it over the entire human corpus. So let's search for aerospace. Since we are aerospace, you see, it started around 1957 or so, when there was a lot of competition between the USSR and USA to get to the moon and also the sky. So, and then you can search for everything you want. So, like for example, bioinformatics. So the fact that it goes down doesn't mean that this is declining. The word usage is declining. This is a relative word usage. This axis, the vertical axis. So what it basically means is that there has been new words that are used more frequently than aerospace. And because of that, the relative frequency is going down, but the field itself is developing. But since it's become a mature field, and the other fields are also growing exponentially, you don't see much of a growth here after 1990. So for example, if you search for Fortran, if you search for Fortran, you see something like this, and that actually marks the beginning of Fortran around 1954, and it goes up and down, and each one of these, if you track it, you see it correlates well with the fundings that were made available to the fields of aerospace or other computationally intensive fields like plasma physics, for example. But again, the fact that it's going down, it doesn't mean that it's declining. It's just the gradual growth, which is just lower than the other more popular programming languages, like Python. For example, if you search for Python, you get something like this. Obviously, Python programming language did not exist 100 years ago. The problem is that we have to make this capital and then make it case sensitive. Now, you get three curves. And I think this is the one that corresponds to Python programming language, the one that is here. Right? You see there's an exponential growth. All of a sudden it goes up, and there is no sign of decline in Python relative to the other words. So yeah, basically you can use this to track the popularity of other fields of science. For example, bioinformatics is a relatively new language. A new field of science, and you can see that around 1990s it has started to grow, and it's still growing exponentially. Right. So if I add Python here, you can see that these two are well correlated. And if you go to the field of bioinformatics, everything is almost done in Python. That's actually how I learned myself Python. So you can see that these two are well correlated with each other. Or for example, if you go to aerospace, Fortran, you get a curve like this, which correlates almost well with the field of aerospace. You see. So this just means that some of the programming languages very specifically designed to tackle specific tasks in a specific field of science. So because of that, Fortran has been really highly specialized, and it's very popular in specific fields of science, like for example plasma science and aerospace. And if you go to, for example, bioinformatics, you don't see much of Fortran there, except that in the lowest levels of, for example, Python libraries, there might be some subroutines that people use. People write in Fortran. Anyways, so I just want to tell you a little bit about this. But then one thing about the computer. What are the components of a computer? Do you guys ever know or ever try to find out what the main components of a computer are? Yes. What is it? Just look at the screen. That's all you need to do. Yeah. So you have. So if you want to have interaction with the computer, for sure you're going to have an input device and an output device, right? You have the monitor as the output device. You have the input keyboard as the input device, and mouse and other things like camera. And then besides this, there's also a central processing unit right at the center. And basically what you see here in this figure, what I showed you last time, this is the central processing unit for ENIAC, which is the size of this room almost. But right now, in each one of your devices, like my cell phone, you have a CPU, which is probably comparable to the power of this gigantic machine, but the size of my fingertip probably, or smaller. And then, besides this, you also need a memory, so that you can store things that you do. That memory is called RAM. What does RAM stand for? Awesome. You guys know everything, so I don't need to waste time on these. And I told you about the hierarchy of languages. So in the lowest level of abstraction, you have the machine language, where you have to hardwire everything. So like, for example, if you have a table calculator, do you have a desk calculator here? Yes, okay, somebody has it. Don't worry about it. I don't want it. So if that actually is an example of a fixed program computer, meaning that it can only do things that it was designed for. So the wires and everything have been designed and set up in such a way that it can only do square root or a few other things, not anything more. Like this complex laptop that I have here. But anyway, you can go, but this is not really useful because you have to rewire everything every time you want to do something different. So people came up with the assembly language, which is basically one level higher than the hardwiring, like hardwiring the machine. So you give it special instructions to do things that you want to do. But again, that's not useful because it's platform dependent. So the code that I write on this computer is not going to work on another computer, right? So people needed something that is platform independent. So like if I write a code and I give it to you, you can run it on your own computer, right? So they came up with the idea of compiled languages, C, C++, Fortran. So what is the process of a compiler? What does a compiler do? Any ideas? Yes?
It shifts the language down a level.
Awesome.
So that the language is built on terms. If node wants to practice that language,
exactly, yes. Yeah, exactly. So most of these languages like C, C++, and especially Fortran, if you read it, it's very much like a human language, with a little bit more rules involved in the language. But then what the compiler does is that it compiles and interprets the language, the Fortran or C++ or C language, to assembly, and then assembly does what you want using the machine. But then there's also higher level. Why do you think we need a higher level than Fortran, C, C++? Yes. Exactly. You can, with the higher level of abstraction, MATLAB, Python, Perl, these languages, you can do things in real time. You don't need, with the compiled languages, you have to write your code in a file, save it, and even now, every day I do these things myself, but it's just, I don't know, it's painful. The whole process is painful. You have to write the code and then ask the compiler to compile the file, and it doesn't compile because it has a lot of bugs, it has a lot of errors in it, so you have to fix them and then go back, compile it again, and if it works, then fine, you have an executable file generated there. Then you click on or like for example, ask this executor to run, and then your code runs, right? So it's a very long process. But MATLAB, Python, and Perl basically remove these steps. So everything you want to do, you can do it in real time in your MATLAB or Python environment. So like I want to say x equals 1. It does it immediately for me. I don't need to compile anything. And these are the examples of interpreted languages. Right? So as soon as you type something in these languages, the interpreter, Python, MATLAB, or Perl interpreter, interprets them and then does the task that you requested it to do. And then we have the higher level that I showed you last time. You can ask questions from Wolfram Alpha. Okay. And about this figure, I think this is really important. So I would highly recommend you to have a look at it. And if you look at this figure, you can see Fortran is, yes, the first language, the first high-level language, compiled language that was created. And then this is still going on, and there's a, so in a month I will ask you to download Intel Fortran compiler and also C++ compiler. And the most recent release of Intel Fortran has draft Fortran standard 2015. And I think with C++ it has 2017 draft. Yes? Which one? Yes, it's all fine with me. Whichever you want to use. For the compiled languages, I'm going to ask you all to download Intel compilers because it's free and it's highly optimized. It's probably one of, I would say, it's the best available. But you can also use GFortran, GNU organization. How many of you know about GNU? GNU organization. Okay, so it's a non-profit organization, and it generates a lot of, it develops a lot of compilers for different languages. So you can use GNU compilers, GCC and GFortran. Anyway, what's important in this diagram is Fortran there, C and C++. So you see that C originated from B and BCPL. These are dead now, so everything that's black is dead, doesn't exist anymore. Do you see things well? Yes. And B originated from Algol. Algol, I think, still exists. Or it actually evolved to something different. So it evolved to Smalltalk, which is now endangered. Nobody uses it anymore. We have COBOL. These are the very first two languages, Fortran, COBOL, that are still alive and still in use, even every day. So a lot of business corporations, they use COBOL for everyday things that they want to do. But so one thing that's important is the ancestor of C++. So it originated from C, and then what's a decade? It's around 1980s. And if you look at C, it originated around 1970s. So every decade people came up with a new language that became really highly popular. Fortran in 1954, well, basically the first major release of it was in '66. So it was in the 60s that was released. And then in the 70s we had C. In the 80s we had C++. What about in 80s? I said in 80s, in 90s. We had Java and another one, Python, yes. They're still very popular. Perl has lost its popularity because I think one of the reasons is that Python has become really popular. It's taken its place. So if you, for example, go to Google Ngram and search for Perl, Python. Well, I think I have it actually in the in this graph. Yes. So if you look at this graph, you see Perl is losing its popularity mostly because I think Python is taking its place, especially in bioinformatics. Anyway. So I want you to keep these in mind. So the approximate decade when these languages were created for the first time, Fortran, C, C++, Python, and Java, right? And Python also inherited a lot of things from C++, which inherited a lot of things from C. So a lot of new languages are now descendants of C language. So for this semester, what I'm going to tell you what you're going to learn is to go through this hierarchy from the beginning to the end to classes using MATLAB. And then at the end, depending on how much we have time, I will start again using C++ and Fortran and teach you probably up to functions, not classes, because classes is kind of complex topic. But I think we can do it in MATLAB. We will have enough time. But basically, the idea of class is that we have, for programming, you need two things. You need data, and you have a set of actions that act on those data sets. So in the simplest way, you can just type your commands and use the values that represent your data and let them interact with each other. But then once your program grows, becomes too large, you have to put them in a file. We call it MATLAB a script. And then you define a set of variables because it's difficult to work with values alone. So you cannot define just one. You can use one in an equation, for example, but it's difficult. So it's always good to put that variable in put that value in a variable. So x equals to 1. Now I can use x wherever I want. I can, let's set this to 10. Now x squared is 100, right? Or a square t of x is 3 point something, right? So that gives you a lot of freedom to use variables and then use scripts to handle large parts of your code. But then again, there's a problem because your script can become too large, so you have to modularize your code. And that's what imperative or procedural programming is about. So you have a main code. That's always what I do myself. So if you look at my codes, let me see if I don't have a good example right now. But basically what you do is that you have a main code, which I always name it main. So is in C, in C++. And then you have other functions that do a specific task that you want through interface that you define for them. And those functions can call other functions, other libraries, and so on. So that's the structure of a imperative or procedural or functional language. These are pretty much the same thing. And then around 1980s, this idea of classes was introduced. I think through language Smalltalk, and then Bjorn Strastrup took that idea and combined it with C language to create C++. So both MATLAB, C++, as well as Fortran, and other languages like Python, Java, all of them are object-oriented languages. Except C, as far as I know, there is no such thing as object orientation in C. So all these languages that I named, they are all procedural and functional, but they also do object-oriented paradigm. So with this, I think we are done with this, with the previous lecture. And I'm going to tell you a little bit about the history of MATLAB. What does MATLAB stand for, by the way? Do you guys know? Matrix Laboratory, yes. How about Fortran? Because it has some similarities. I want to know, do you have any ideas what Fortran stands for? Formidable, I don't know, creature or what? No, it's a formula translation. So its name actually states what it was supposed to do from the beginning. So it was designed for mathematicians and physicists and engineers. So, but the creator of MATLAB is, I forgot his first name, Moeller, Cleve Moeller. Okay, and he designed MATLAB around 1980s. And initially, this there's no picture of him here. Initially, this software MATLAB was written all in Fortran, but then they later on translated everything to a C language. And what you see now is all written in C, C++, and a little bit of Fortran involved in it. This is a talk by Clive Moller, and it's really interesting talk. I would recommend you, if you have time, watch it. It's not part of our course, but I would highly recommend you to watch it. There is a link also to a higher quality of it in MATLAB website that you can watch. So I'm just going to tell you a couple of reasons why we chose MATLAB for your class. And the reason is that it's quite widespread in every engineering class, engineering field almost, and also as sciences and medical schools. And there's almost no day that I'm not using MATLAB for my own work. If you go to bioinformatics or biology, for example, you see a lot of Python there. You don't see MATLAB much, but there's a lot of Python. So these languages have become field specific to some extent. So MATLAB is very popular in engineering and sciences. And it gives you a lot of abilities to manipulate arrays and matrix, just like Fortran does. And a lot of other things. I'm going to leave this to yourself to read them. But it has also some caveats. It's not free, and it's kind of slow compared to other languages. Do you know how slow is MATLAB compared to C or Fortran? Any guess, ideas? I don't know myself. So, but I know it's much slower. But I can tell you other one. I know for Python, I've compared it myself. And Python is comparable to MATLAB, I think, mostly, in terms of efficiency and speed. And Python can be up to 500 times slower than a for loop in Fortran, for example. So that means a task that takes only 1 second, or let's say you write a program that takes 1 day to run in Fortran, it's going to take 500 days in Python if you wrote the same thing in Python. So the fact that you get more freedom to express what you want in the language, the fact that you have higher abstraction level, comes with a compromise in the efficiency of your code. So your code is slower and slower as you go to higher abstraction levels. And if you go to this page, NASA Guru web page, I think they have comparison for all different tasks between Python, MATLAB, and Fortran, and also Java. So, like for example, if you compare for, I think this is a for loop test. For for loop, Python takes 48 seconds. MATLAB takes 2 seconds, which is faster than Python. And Gfortran and iFort takes only 0.27. iFort is the Fortran compiler, Intel Fortran compiler. So it's about how many times? It's 10 times faster than MATLAB, and 100 times, about 200-300 times faster than Python. Okay, and so is C, but C is not here because apparently NASA doesn't like C. So that's one of the caveats of MATLAB. So if you have an intensive, computational intensive code that you want to write, you might want to write the kernel, the computation intensive part of your code in other languages like Fortran, C, or C++, and then write the higher level parts in MATLAB, and then call those functions that you wrote in Fortran or C from your MATLAB code. I have done this with Python, and you gain a lot of speed. And then you don't know about object orientation right now, but later on, if you know already Python or other object-oriented languages, you might find the OOP features of MATLAB a little bit strange. So you can now do the same things that you do in Python, for example, which is kind of frustrating at some point. Right. So I told you that MATLAB is functional, imperative, procedural, and object-oriented. So it can do all different tasks that I showed you, functional programming through object-oriented programming. I told you that it's an interpreted language, so as soon as you type something, it does it for you. You don't need to compile the file. and then run it. And then here are a couple of things for the rest of the semester. If you want to keep them somewhere, bookmark them in your browser. I think the most amazing thing about MATLAB is that it has an amazing documentation. So basically, if you follow, in my opinion, if you follow the documentation of MATLAB, you don't even need to take a class for MATLAB to learn it. And that's basically what I have done mostly. I took a course a long time ago, like 10, 20 years ago, but I never learned anything from it. Everything that I wanted to do, I learned it by myself. So hopefully you will learn something in this class. I'm not saying that you won't learn anything. So, and the other cool feature of it is that MATLAB has a lot of educational videos. So if there's any concept that you don't understand, you can go to this link that I have here, MATLAB educational videos, and just search the video that you want to, for example, the topic that you want to learn about. Loops, object-oriented programming, or anything that you want, plotting, anything. And then there's a video about it for sure that you can watch and learn how to do it. Right. So how many have MATLAB already? How many don't have it? A handful of people. Okay, for those who do not have it, I offer you two things. If you totally hate MATLAB or don't like to install it on your own device, you can go with GNU Octave. GNU Octave is an alternative to MATLAB, which is free, and it's mostly compatible with MATLAB. So people started to reverse engineer MATLAB in a new software called GNU Octave. So it mimics pretty much everything that you can do in MATLAB, but it's not totally compatible. But it's at no cost. But since you have MATLAB for free, I would highly recommend you to all of you to get MATLAB. But here's the thing. If you don't have it right now, you can go to your browser, Control 9, T, search for MATLAB Online. MATLAB Online. You click on it, and then it asks you to enter your credentials. So like, I want to use MATLAB Online. Those who do not have it, you can do it right now. Even those who have it, you can do it like this, like what I'm doing right now. So do you guys all have a MATLAB profile? Okay, if you have it, then search for MATLAB Online. I think I'll have it also somewhere in the lecture notes. I don't know where exactly. Online, if you search online, it might be there. Yes, using MATLAB Online in your browser. So if you search for online and then click on this link here, it takes you to the online server for MATLAB. And once you log in, you can use MATLAB environment there with no need to install MATLAB locally on your own device. It has a couple of limitations, like for example, you cannot, I'm not sure how you could work, for example, with files. Like for example, you have a data set that you want to read using MATLAB. I don't know how that would work, but probably there are ways. So for now, if you have difficulty using MATLAB on your device, you can use the online version. This is a function that I wrote a long time ago, I think. Yes. So I can, but so I have a question. How does this MATLAB Online work if it's not on my desktop, if it's not on my laptop? There's a remote server. There is a computer somewhere else, probably in MATLAB headquarters, not just one, probably thousands, because it can accommodate at least our class. All of you can log in and use MATLAB, right? So it means that for each one of you, as soon as you log in, there's a computer that you can use to work using, you can interact with. So like for example, if I type x equals 10, I get the exact same thing as I get in my own local device. So if I go to MATLAB here, x equals 10, the same thing. But it's kind of slower because it has to communicate with the remote server and bring everything back to you, right? But this is not a complete solution to your problem. So I would highly recommend you, if you don't have it, go back and install it. locally on your device. And then one last thing about MATLAB editors. So the editor of MATLAB itself is an amazing editor. So it can fix your errors automatically. It can do auto indentation in your program. So for example, if you type for I equals 1 through 10, and this is not correct. For I equals 1 to 10, you click and you see there's an indentation here for you. 4, 1, 2, 3, 4. So automatically it takes you to it puts four white space ahead of your line so that you can type whatever you want. So display hello world, end. You see, as soon as you type end, it takes it back to the beginning of the line. You see it well? Okay. Now, let's say if I wanted to run this code, you have to save it. I'm going to tell you these things later on, but let me save this here for now. Yes, sure. Save it there. Okay. Now, if I press F5, it runs it. It says, do you want to change folder, the working folder? Yes, I want to change it. And it types hello world 10 times for me. But I'm going to tell you about for loops later on. It's not the topic of today. But I just wanted to show you that you can use MATLAB editor itself for these cool features that it has automatically. And if I type, for example, if I do a syntax, if I type something wrong, end F, you see, and if I press enter, it's going to give me an error. You see, it says an end might be missing, possibly matching 4. So it automatically detects that there is no end for this for loop. So as soon as I make a mistake, it tells me that you made a mistake, fix it. So MATLAB editor itself is really useful, and I would recommend you to use that. But if you don't like it, you can use Sublime or Notepad++. If you are in Mac, your choice is probably Sublime. If you are Windows, I highly recommend you to use Notepad++. It's an amazing software once you learn how to use its cool features. So you can download it for free. It's here, but sadly it's only available for Windows. I can show you a couple of cool things that you can do with it. So like, for example, you can do block editing. That's the most amazing thing that I like about it. I select this, and I select all of it, and I type Amir instead of, and I press Ctrl Z, and I remove everything. Everything is back to where it was. So it's a very powerful editor. And what I do myself personally is that I edit my codes here in Notepad++ because it gives me a lot of power to manipulate the text in the code. And then at the end, I open it in the MATLAB editor. Let MATLAB check if there is any errors in my code. So if there's any error, it can automatically tell me. So for example, in this code, I don't have any errors. It doesn't tell me if there's any error. If there's any one, so like for example, if I add a FD here and then like this, it's going to tell me there's an error soon. Come on. Well, it's trying to embarrass me for now, so we'll skip this. Anyway, so these are your two options probably, and there is a lot of other editors, but they are less powerful than these two. Which MATLAB version you should use? 2017. If you download get the license from UT, it gives you the latest version. And then a little bit about MATLAB environment. What is this environment? The file editor, I would say, or the editor section of your MATLAB. This is the command line. You can type anything and get an answer in real time. So like for example, if you assign y equals to 20, immediately you see that the y appears here. So you have a y variable in this working area, working directory, in the workspace of your MATLAB environment. And if you click on y, it shows you what y is. Y is a matrix that has only one element and its value is 20. Okay, and what is this area? The directory tree. So it shows you the working directory of MATLAB. So right now I'm in C users Amir. Right. If you have a code that is in another folder, MATLAB is not going to find it. So if you want to use a file, run a file, you have to put your code and that in MATLAB working directory, or change the MATLAB's working directory to that folder. Otherwise, it's not going to work. Right? So, like for example, this main. If I try to run this code main, to run a code, you can either press run here, the button here, or press F5. Or just type the name of the code. So like if I type main, the name of this script is main. If I type main, it's going to give me an error because I'm not in a directory where this main code lies. So if you see, undefined main, there is no main. And it's smart, so it gives you even a suggestion. Did you mean mean? Oh, I didn't mean mean. I meant main. The problem is that you are not in the working directory for this main code. So now if I go to this main code and press F5, it asks me, do you want to switch to this folder that contains main directory, because I'm not already in this main directory. And if I say change folder, it starts to run it. If I say add to path, what basically it does is that it keeps the working directory as users Amir, C users Amir, but it adds this new directory as a path to the path folder for MATLAB. So whenever later on I want to run this code, I don't need to switch to the working directory. I don't need to switch the directory to the folder that contains this main code. MATLAB automatically searches all the folders that are in the path directory, in the path list of MATLAB, and then finds the code that's there. It's not recommended, so I would always recommend you to just change folder so that you work directly in the folder that contains your code. Right? So a couple of cool things, like for example, if you type Y, it gives you some random, sometimes root messages. So be careful to not mess with MATLAB, ask him crazy questions. Why? Too full, it's all good. I don't know what it means again. And if you try more, it starts to get nasty, so don't do it. So, but there are other things, like for example, if you type who, for example, it tells you what variables you have already defined in your workspace. So look at this. You have in workspace, you have answer, you have I, X, X, Y, and it types everything for you here. Now here's one thing. Look at this. This is X and this is capital X. Why do I have two variables with the same letter? How could it be possible? What was that? Two separate is what? Variables. Yes, these are two separate variables, but how could this happen? For example, you cannot do this in Fortran. It's because MATLAB is case sensitive. Okay, so capital X has a different meaning than lower x. Okay, so you can have y equals 10, and you can have y equals y caps lock equals 20. Now if I type y, small y is 10, capital Y is 20, right? So be very careful with this because it can put you in a lot of troubles. With MATLAB, it's not going to affect you much because MATLAB has a strong debugger and editor. But with other languages like C++ or C that are case sensitive, it can cause some trouble for you in debugging. Okay. Now, a couple of other things. So, a few things that are really useful for you throughout the semester. So, if you want to see, for example, what kind of things you can do with MATLAB, you can type demo and press enter. When you press enter, a new window opens up that has a lot of examples for doing different things. And if you click on them, it's including videos. So for example, getting started with MATLAB. What do you want to do, what MATLAB can do for you. You can click on the link and it takes you a browser that has videos about how to do things. So as I said, to be honest, you could do everything by yourself. Not much of a need for a class, but that doesn't mean you shouldn't attend a class. We're going to talk about things that are not part of MATLAB. So what our purpose is to teach you how to solve differential equations, how to do Monte Carlo calculations, how to calculate number pi, approximate number pi, which is a really cool thing. So we'll see later on in this class, and it's going to get really interesting. And then you can use help to get help about anything that you want. So like, for example, what is this thing who that I'm using? For example, if I type who, like if I type help who, it's going to tell me what who is, what who does, for example. And then there's a couple of other commands that you can just read it by yourself and learn what it does. But I would highly recommend you to use them once for yourself and learn what it does exactly. The most important one is duck. That's probably the most important. I use it every time I work with MATLAB. So for example, if I want to know what function sine does, I do duck sine, and it opens the MATLAB manual for the sine function. It tells me sine, for example, is a sinus function and does these things for you, right? So this is probably the most important command that you need. Auxiliary command, duck, which means documentation. And then you can use also pwd as you used in Linux on bash command line, git bash. So if I type pwd here, it tells you which directory you are in. If you type dir, it tells you all the files and folders that exist in that folder. So dir, this. ls doesn't work, I think. Oh, the ls also works. So both of them, ls and dir, work. And that's it. I'll see you next time. Next time we'll start real programming, MATLAB.